Hello, Facebook. So today I'm at the Pole Studio with Amy and friends, and I wanted to talk to you about why stars explode and why you're made of star stuff. Because though I'm into business and though I'm into health and nutrition, I'm going to go in here so not to bother them. And though I'm into health and nutrition, I'm also very much into physics. So when the universe was very, very new, it was essentially like a mix of these small particles, these things called protons and neutrons. And these small particles also had electricity going around them, but not bound to these individual protons and neutrons. As the universe cooled down, the protons and neutrons came together, and the electrons started to orbit them. So these are your very, very first atoms, right? So gravity pulled all these atoms together into big gaseous balls, and these big gaseous balls essentially started to turn into stars. Now everybody knows what stars are. You've seen them out in the sky. They're these big heat-emitting things. The sun is essentially a star. But what is it that why is it that stars give off heat? Do you know? Have you thought about it? Well, let's say that you've got the simplest possible atom, which is a proton and a neutron being orbited by an electron. That's like the simplest possible atom that can exist. Was it one proton? Anyway, so you've got this atom, and another atom comes along, and if they happen to be able to touch, what happens is as a result of them joining, some energy is lost, right? Some energy is given off. Think of it like you have an elastic band around something, and that elastic band's keeping it in place. And you have another thing with an elastic band. If you put those two things together, you no longer need that second elastic band, so off it goes. That's what happens in stars. So because of the gravity, things get pushed so close together that these atoms can fuse and they lose an elastic band. Right, and that's why stars give off energy. Really, this elastic band dispersal. It only happens in stars because have you ever tried to put a magnet, the two ends of a magnet, two different magnets together? They repel. Well, exactly the same thing happens at an atomic level. So if you try to get these two particles together normally to get them to fuse in this way, they won't. Right? Which is why you need a lot of gravity and you need a lot of energy in order to get them to fuse and then give off this energy, which is why stars have to be very big in order for it to work. It's also why, when you've got scientists trying to create fusion energy at the moment, it's why it's really difficult. That's what they're trying to do. They're trying to create these conditions whereby these magnets naturally clip together and give off energy. Anyway, so this goes on in a star, and what happens is the explosions of all of these particles that form up a star push the star outwards like this. You think it's a big explosion going like this. But gravity takes over this and keeps it in. So you've got this balance between pressure pushing it out and gravity keeping it in, and a star then maintains a certain size. What happens though is as a star starts to burn all of its fuel, it reaches a point whereby this outwards fire is going to slow down and stop, right? So it can't physically burn any more fuel. So you can imagine what's going to happen. What happens if you start to put out a candle? It runs out of fuel. It's not going to carry on to burn. So what happens then is gravity takes over, and you see the star crunch back. All of the mass that's in there crunches back because you've no longer got this explosion pushing it outwards. So, essentially, what makes a star run out of fuel? Well, all of these simple elements that have been created, that have been combined. So you've now gone from like hydrogen to helium. You've got all of this stuff in the star that is now a combusted fuel. So it's run out and it compresses. So, but why does it explode? Right. So if you imagine you've got a proton and neutron in the middle, you've got an electron orbiting it. Think of it like a spring like think of it the same way as a magnet. If you got two magnets together, you'd have this springiness. Well, there's actually a limit to how close you can put things together before they become solid, right? In a spring, you hit that point where it's springy, and it's the same when you try to pull particles together to each other. There's a limit on how close they can get together. So as a star runs out of this energy, pushing it out, and it starts to accelerate inwards on itself, it reaches this point in the middle where the spring cannot get any tighter. And all this energy that's coming in hits this thing and it explodes because it has to bounce off of something, and it bounces off itself. And at this point, at where a star is what's called a star going supernova, at this point when a star goes supernova, there's so much energy that even these, we had the hydrogen becoming helium, even the heliums then combine to be even heavier elements. And that's how we create all sorts of things like gold and platinum, and all these heavy elements that exist happen at that point of explosion. Very little of these things are created whilst the star is burning its fuel because there's not the energy there. It relies on this ultra fast, this ultra powerful supernova explosion. Now, the interesting thing about this is that you and me, all the metals that we see, everything around us, these aren't made from the hydrogens and the heliums and stuff. These are the heavier elements, the carbons, we're made of carbon. Even water that's in our system is a heavier element. We are made of things that are only able to be produced in this universe by stars going supernova. So that is why you are made of stardust, and that is how it all happens. So I hope you found that interesting. I got a bit excited there.